I'm Jean-Christophe Baret. I'm working at the CRPP, which is a mixed lab from CNRS and University of Bordeaux. Living systems such as bacteria, yeast and fungi have extraordinary abilities. They can renew themselves, transform materials efficiently and produce all kinds of substances like antibiotics, sugar, proteins, polymers, gels, particles. But cells are only efficient in a specific environment. They are not necessarily adapted to produce materials in the way we want them to do. By getting inspiration from this living system, in a decade or so, we can go one groundbreaking step further. Build cells from scratch using the fundamental principles of life. So these cells would be better adapted to industrial environment or optimized for their production capabilities. In my lab, we reassemble nature building blocks, lipid, proteins, peptides, nucleic acids, to create man-made artificial functional systems. And if nature is not as efficient as we need, we complement it with artificial building blocks produced by material engineering, so it will perform the desired task. And this is the area of bottom-up synthetic cell research. I look at single cells and measure their ability to make chemical reactions. For this, I develop new technologies that allow to select the cells that are the best for a specific task. I work with microfluidics, and just as microtechnology has done for information technology, the technique of microfluidics is a game changer in our field of making synthetic cells from the bottom up. Microfluidics is the technology of manipulation and control of fluid and soft matter at small scale. In my lab, we create chips to control flow and use them to manipulate the individual components of cells. We combine the functions of living matter in new ways, for example, to rebuild simple metabolic units. Combined to the young microtechnology of 3D printing, this makes it possible to assemble these synthetic cells into larger systems. Fully integrating this technology is the next challenge that might take a few years. I myself envision that we will soon be able to create and upscale the production of artificial cells for many applications of industrial interest, like waste degradation purposes, the transformation of bioresources. And more generally, synthetic cells will provide new solutions for the sustainable industry of the future.